Assalamualaikum warahmatullahi wabarakatuh. My name is Binti Matrix number 073806. So we are from group 6 presenting our cafe food ordering system. So this is our team members. Next, we move to the background of the system. At Universitas Jusoh campus, students they order food using papers. They write their order, put it in the basket, and wait without knowing the status. This causes confusions, long waiting times, and wasted times, especially for students with a lot of assignments and classes. So we propose cafe food ordering systems so that students can order online, view menus, choose pickup times, and get updated like preparing or ready for pickup. Cafe owners can also manage their menu easily. They can add, edit, or delete unavailable menus, view customer orders, accept or reject them, and update their order status.
My name is Binti. My matric number is 073377. Let's proceed with functions in system. For both users for our system, which are customer and cafe owner, they are both expected to be able to log in and log out into the system. For customer, they can register into the system as a new user by creating an account. After successfully login, they will be able to view all available menus in the system. If they want to order something, they can add the item menu into their cart. Customer also can update their cart by changing the quantity of their order. If they change their mind, they can delete the item from the cart before placing an order. They can also view the cart at any time to review back their selected menus. Once ready, customer can place an order through the system. The order status are still in pending. Customer can also delete the order. And lastly, customer can view their order status, such as whether the food is being prepared or ready for pickup. Now moving on for cafe owners, the system provides several functions for cafe owners to be able to manage their menus and order efficiently. Cafe owner can add new menu to their specific cafes in the system. They also can update existing menu, such as updating the price or the food name. If needed, they also can delete the menus if the food are no longer available or the stock is low in quantity. Cafe owners can also accept or reject the customer orders depending on food availability. If the order was accepted, cafe owner can update the order status, such as changing the status from pending to being prepared or from being prepared to ready for pickup. Now I would like to explain about formal specification. Formal specification is a mathematical and logical technique used to describe system functions, behavior and constraints in a way that is clear, precise and unambiguous. It is means to avoid misunderstanding because everything is defined using formal methods. The main role of formal specification is to verify whether the system requirements are complete, correct, and consistent before we move on to design or implementation phase. It also ensures that both developers and stakeholders share the same understanding on what the system should do, which helps avoid costly mistakes later in the project. In software development lifecycle, formal specification is typically applied during requirement analysis and specification phase, where we define what the system must achieve. For this project, we use Z specification, which is one of the most commonly used formal methods. It uses mathematical notation and schemas to clearly define the structure and also behavior of each functions in our cafe food ordering system. Z specification allows us to verify our design and also ensure that all operations behave as expected. Next, let's proceed with the system formal specification for customer side of our cafe food ordering system using Z specification. In our system, customer can log in, register, manage their cart and also manage their order. These actions are modeled using Z schemas, which defines the system structure and behavior using set theories and logic. Next, we use operation schemas like register customer, where we define that customer can only register a new username that does not exist in the system. Once they have registered, the new username will be stored in the system. Login customer schema check the customer credential. If it is valid, then the customer can log in into the system and also will be able to view the system. A logout customer schema allow customers to log out from the system. Next is the cart module defined in cart schema. There are 4 operation schemas in cart module. The first one is add to cart, where customer can add the food item into their cart only if the menu is exists. The second one is update cart schemas, where customer will be allowed to modify the quantity of the food in their cart. The third schemas is delete cart, where customer can remove an item that they no longer want. And the last one is view cart schemas, where customer can view their current content of the cart. Finally, we have order schema, which handles the full ordering process. There are 3 operation schemas. The first one is to submit order, where the items in the cart are transferred to order list. The second one is to delete order, where customer allowed to cancel their order only if the order status is still pending. And the last one is view order, which returns all orders placed by customer. For cafe owner, they are allowed to manage their menu and also the orders taken from the customer. We start with cafe owner state schemas, which keep tracks of usernames, password and also login credential for owners. There are also other schemas like register cafe owner, which add a new cafe owner to the database if they don't exist, and also login and logout schemas, which manage authentication and also session transitions. Next, the menu module, which is described in menu schemas. There are 4 operation schemas here. The first one is add menu, which allows cafe owner to insert new food and price to their menu list. The second one is edit menu, where cafe owner can update the menu names and also the price. The third one is delete menu, where cafe owner can delete the menu that is unavailable for that day. The last one is display menu, which returns all available menu in the list. For order management, we use student order schema. There are 4 operation schema. The first one is accept order, which adds the customer order to the list of accepted order. The second one is reject order schema, which removes the order from the list and returns a rejected result if the item is unavailable. The third one is update order schema, which modifies the order status, such as changing from the pending status to be prepared status. And the last one is display order schema, which allows cafe owner to view all the orders made by students. Each of these functions is written in CSD schema with clearly defined input, output, and changes made to the system state.
Next is student order theorem. In this theorem, we define what happens when a student places an order through the student order operation. It states that the students involved must be part of the valid student set. The orders placed must come from the valid order set. And lastly, the enter relation created must correctly link a student to an order. This ensures the system maintains correct and valid data when recording student orders. Next, this theorem describes what happens when a student's food order is rejected. It says that if a valid student is involved in the reject order operation, the system will return a result of rejected. This ensures the system clearly communicates the rejection's outcome and only process valid student inputs. Lastly, this theorem defines the preconditions and post-condition of the update order operation. It ensures that only valid students can update an order. The order being updated must exist in the system, and after performing the update, the system will return a result, which is always from the valid set of results, such as success or error. This helps maintain system correctness and ensures that no invalid data is processed or retained.
So these are the theorem involved in customer's operation. First, we have aggregate theorem. So for this theorem, the verification is to ensure that the operation only runs when customer, food and quantity are valid. That is for validation. It is to confirm that only positive quantities are allowed and prevent adding unknown values. So the key point for this theorem is to prevent invalid or duplicate items from being added to the cart. Next is delete cat theorem. So the verification is to confirm deletion logic is correct and input types are valid. The validation for this theorem is to ensure that only existing items are deleted from real customers. So the key point for this delete cat theorem is to maintain cart consistency by avoiding invalid deletions. And the last one, we have submit order theorem. The verification is to check that the item is in the menu and price matches. The validation is to make sure orders can only be submitted with correct food and price. So the key point is to ensure valid type items are moved to the order list properly. So in conclusion, the cafe food ordering system was developed to address inefficiencies in the manual ordering process happened at Unisa Besar campus. So by implementing structured modules, the system enhances both user convenience and cafe operational efficiency. So the use of formal specification using Z notation allowed for precise modeling of system data, operations and constraints. So additionally, verification and validation of schemas and theorems ensured logical consistency and system reliability. So overall, the system provides a faster, more organized and real-time food ordering system for students while simplifying order management for cafe owners. So I think that is all from our group. Thank you.